The US Department of Defense continues to push for the use of open architecture solutions as a means to get better avionics hardware into the field more quickly and at lower cost. Major defense suppliers like Bell have embraced the Modular Open System Approach to enable quick, cost-effective new technology integration. In this video, we will explain how Rapita works with companies like Bell and other ecosystem partners like DDC-I and North Atlantic Industries to facilitate compliance with the Future Airborne Capability Environment, or FACE standard. Founded in 2010 to develop an open architecture technical standard, as well as business models for implementing FACE standards in systems. The purpose of the FACE standard is to provide a reference architecture based on segments, which can be composed to meet the final system requirements. FACE provides the logical interfaces between these segments to allow for portability and reuse. The operating system segment, or OSS, provides a foundation to the other segments and thus is shown above the others in the diagram. The FACE standard builds on existing standards. In the case of the OSS bundle, it builds on the POSIX and ARINC 653 standards. Avionics system designers and integrators designing to the FACE standard under the safety, safety extended, or security profiles must include an ARINC 653 partitioned operating environment in their architecture. Assuring partitioning on a unicore is challenging, but largely a solved problem. Assuring partitioning on a multicore system is much more difficult. The use of an ARINC 653 compliant RTOS like DDC-I's DOS meets a FACE requirement and implies partitioning is achieved. However, these advanced RTOS technologies are not sufficient in themselves to prove that partitioning is robust. The FAA's CAS 32A position paper sets out specific objectives that need to be satisfied when designing multicore systems according to DO-178C guidance. CAS 32A is soon to be formalised via the AC 20193 Advisory Circular. FAA guidance has often been adopted by US military airworthiness authorities, and CAS 32A is no exception. CAS 32A documentation extends the partitioning concept for multicore processors, with specific reference to providing evidence that partitioning is robust. In a multicore system, multiple applications can now run simultaneously, each on their own core. Some resources are private and exclusive to a single core, such as the L1 cache, as shown in this example. However, other resources are shared, such as the L2 cache, main memory and I/O devices. The applications on different cores can thus contend for access to these shared resources, impact each other's performance, and down the isolation between partitions. Only recently have early adopters attempted to use all cores with a mixed criticality of software by following the guidance in DO-297 and CAS 32A. This approach is complex, with independent applications running within the same partition window on separate cores, despite the applications being certified at different design assurance levels. In this case, independent partitions with different criticality are able to run simultaneously on different cores, within the same minor time frame of the schedule. Independent partitions running on distinct cores now compete for shared resources. That contention can cause delays, thus increasing the software's worst-case execution time. Mitigation of multicore interference requires that partitions be isolated from each other. Some isolation mechanisms are provided by a multicore RTOS like VxWorks 653 Multicore Edition. Such RTOSs can manage processor cores, ensuring the usage of any one application is deterministically bounded within its partition. Verification that multicore interference channels have been mitigated is an essential step in meeting AC 20193 and CAS 32A objectives. Rapita Systems have developed their CAS 32A compliance solution to help meet these objectives via a combination of advanced tooling and engineering services. The Rapita Systems approach to multicore timing analysis uses two phases within a test methodology for measuring multicore interference channels. The first phase is platform characterization, wherein the platform is defined as both the computational hardware as well as the RTOS. In this phase, we check the outer bounds of possible multicore interference by competing rapidemons against each other on all cores. Rapidemons are applications that create targeted interference on shared resources. Because rapidemons are tuned to stress a single targeted shared resource, this provides a signature of the performance possible when cores compete continuously for that resource. This phase can be done even before application software is available. The second phase is software characterization. Individual software applications intended for use in flight are first measured running alone on a core, while the other cores are dormant, providing a baseline measurement of the software timing behavior. Next, we measure the increase in worst-case execution time in the presence of rapidemon adversaries running on the other cores. By comparing the worst-case execution time with and without the rapidemons running, we can quantify worst-case multicore interference. This can be measured against system requirements. Rapita have designed the CAS-32A compliance solution to work seamlessly with integrated modular avionics, or IMA, workflows. Using the Rapita solutions, suppliers and system integrators can accumulate certification artifacts over the course of several independent verification efforts. Even with the incremental verification benefits, the complexity and number of interference channels in a multi-core avionics system require a large number of tests. Thus, tool automation is important to keep the schedule and cost of verification reasonably constrained. The Rapita approach automates key stages of the workflow using both rapidemon interference generators and the Rapita verification suite tools. If you would like to learn more about how Rapita Systems and our ecosystem partners can help you build and verify your FACE platform, please use the contact options here.